Right, let's begin. So hopefully everybody can see this. So welcome everyone to our webinar on the reuse of steel and our journey to zero carbon. Today we're going to be talking about the research we've done on this topic, some of the challenges we've faced along the way, and how we envisage that we're going to get past them.
Yeah, thank you very much everyone for joining us. So hi, I'm Ruth Chisler. I'm a senior structural engineer here at Symmetrys.
I'm Matteo. I'm a structural engineer at Symmetrys.
So if you don't know about us, Symmetrys were founded in 2006, and we work on a whole variety of projects, ranging from the small scale private residential through to much larger commercial developments and on a whole range of other sectors. We also have a dedicated civil engineering team here.
Yes, and at Symmetrys, we're really into our sustainability. We're very dedicated to our research and development in that area. And hence why we founded the sustainability group, which Ruth and I are both founders of.
So in the sustainability group, we work on a whole host of things to improve our sustainability performance, both on our actual projects, but also within ourselves, just as a business.
Yeah, we're looking at research into construction materials, basically to see how we can design more efficiently with those. And we're looking at using materials that are beneficial to the planet as opposed to detrimental. And that's all because of the climate emergency that we are in. I'm sure everybody here is very much aware of the climate crisis. It's all anyone seems to talk about at the moment, and rightly so. The IPCC report states that we need immediate and drastic change to limit global warming to 1.5 degrees. As part of this, Symmetrys have signed up to Engineers Declare. And as part of our commitment to that, we've begun to research reuse of steel, as it's a material with a relatively high embodied carbon.
So what is our particular story of steel reuse, and why are we looking at steel reuse? So it's something that's been talked about broadly for many, many years, even decades, but it's all largely been in theory, and the practical application of it has actually been very limited. Generally, it's been only around demountable structures or rebuilding the same structure, but just in a new location. So we're really looking at actually reusing it for a new building. And recently we were challenged by this on a project with a client to reuse steel. So this led us to really investigate the implications and the viability of using reclaimed steel, interrogating the practicalities of steel reuse, and producing a genuine and an actionable roadmap. So that's what we're going to talk about, but what's actually happening right now?
Yeah, so just as a quick run through, we're going to take you through how steel is created in the first place, for those of you who don't know. It is a material that's mined from the ground in the form of iron ore. That iron ore is processed along with limestone and coal and taken to a manufacturing facility. All those materials are added into a furnace, heated to a high temperature to make the liquid iron. Once that molten iron has been created, it's piped off and sent to another furnace where it is heated to really high temperatures, and that's a blast oxygen furnace. So that uses high-powered oxygen jets to heat it really, really hot, and that's where you get your steel from. Obviously, this is a highly energy-intensive process. It locks a lot of embodied CO2 into steel sections. That's from the mining of the raw materials all the way through to the actual production. And obviously mining is destructive too, or can be very destructive to local habitats. So the more that we can limit this, the better. And that's where reusing steel comes in, and recycling steel. So we recycle quite a lot of our steel. 98% of it is actually recycled, which is fantastic. And steel's amazing for that because it can be continuously recycled without any losses to its structural properties. So the process of recycling steel is relatively straightforward. The steel structure is demolished. It's cut into small lengths and transported to a recycling facility. And there it's added to something called an electric arc furnace, which uses electricity from the national grid to melt that steel down. Now, an electric arc furnace can be charged with 100% scrap metal, which is obviously really efficient, or it can be charged with a combination of mined material and the scrap metal. As I mentioned, the electric arc furnace is run from the national grid. So its embodied carbon associated with steel that comes from an electric arc furnace is really dictated by how efficient and green your grid is. Obviously, 98% of steel is recycled, but unfortunately, that's not enough. Our demand for steel is so high that 63% of virgin steel is still used in the UK today, despite all of this steel that we're recycling. And it's really an indication of us needing to design more efficiently so that we just use less steel, we're reducing. But why reuse steel? Well, the sad fact is that 1% of construction materials are actually reclaimed. It's an incredibly low number, with a lot of construction materials just going to landfill. Obviously, in the case of steel, it's great because you can reuse it. But as I mentioned, electric arc furnaces actually have embodied carbon associated with them. Even though you're recycling that steel, you're still having to heat it up, smelt it back down, and recast it. If an electric arc furnace is in somewhere like Poland, which uses a lot of coal, their coal-fired power stations are going to be powering that electric arc furnace, and it's going to have a higher embodied carbon than, say, somewhere like Denmark that has quite a green grid. So really, we want to be looking at reusing steel sections that have already been created that have a reduced embodied carbon, which we'll come on to later.
So how are we going to reuse steel today? And that's why we're doing this. So obviously the trio of the 3 R's is reduce, reuse, recycle. So we need to start reusing. And we also need to start being more efficient in our design. And this also really chimes in with the ICE President's Address, which is all about material efficiency and design efficiency. So how can we increase that and also steel reuse? So what is our actionable roadmap? So first off, we envisage this process is currently likely to be driven by clients and developers, and they will be, a key stakeholder in this. So the first stage of the process really is, as a team, to identify a suitable steel building. Ideally, we would refurbish as much as possible, but sometimes demolition is necessary. So of buildings that have been earmarked to be demolished, which buildings are suitable to reclaim steel from? So once we've identified those buildings, we can go and inspect the steel, assess the quality, the suitability for reclaim and reuse, and any potential issues around deconstruction. We can approximate the amount of steel that we think we are going to be able to reclaim from the building and start looking at any post-deconstruction processes that may be required, perhaps to do with finishes, intumescent, and start really de-risking the purchase of this steel. So then once we've done those inspections, we can start planning for the deconstruction. This will require engagement between the demolition contractor and the design team to plan that deconstruction process. How do we take down the steel to maximize the amount usable? How do we manage any of those processes that we've identified, any of these issues we've identified in the inspection stages? For instance, it's very common at the moment to drop cut beams. This, as we can talk about and we'll have a little bit later, but you lose steel length there, for instance, rather than blowing the bolts. So these are all the kind of things that we can discuss in this planning stage to try and make sure that we maximize the amount of steel that we can reclaim and we can reuse. For things like columns, for instance, at the moment it's standard practice to bring them down level by level, but can we look at ways to drop them between their splices so you get much longer lengths for reuse? And we can really start at this stage of the process to look ahead to the further design program. So once you've planned that deconstruction, it can be carried out. Ideally, at this stage, we would start grouping the steel, as will become apparent later, based on the section size, the location of the building, detail, such as finishes, the use of the steel, and any other indications we might have based on potential fabrication information. After deconstruction, the stockist, stockholder will then collect. So then we can go and test the steel. And this is where the grouping is really, really important, because we can test the steel based on those groups, which at a maximum, the recommendation is about 20 tons. And testing will be a mixture of destructive and non-destructive testing. At a minimum, you need to assess what the steel grade is, and depending on the requirements for reuse, you might require further tests for things like subgrades and toughness. Alternatively, we can make safe assumptions based on steel grades, existing use, and depending on what that planned reuse is. There are lots of test centres already available in the country who actually provide this service. Typically, it's done more for things like offshore and very large industrial rather than construction, but steel is steel. So actually, this is a relatively one of the more straightforward parts of the process, and we have lots of industry currently capable of doing this. Now we come on to preparing the steel for reuse. And this is one of the aspects that can be potentially more challenging and involves more engagement with some of the stakeholders and the fabricator. So here we'd be looking at potentially removing any undesired finishes, any paints, any intumescent, maybe there are shear studs, additional stiffeners, etc., that we don't need. And one of the problems here is with fabricators is things like potentially contaminating their machinery, from shot blasting processes. And this is one of those issues that we can pick up early on at the inspection stage, and we can plan for prior, so we can know what we're doing and can go ahead and take it forward and be assured that we are going to be able to actually reuse and reclaim the steel. So then once we've prepared the steel, we can fabricate it for the new use. So we can add finishes if that's necessary, add new connections if we require new penetrations. And once it's been fabricated, we can deliver it to the site. We then come to construction, just as we know now, with the installation of our reclaimed steel. But rather than, as has been happening generally now, where it's take down a building, move it, build exactly the same building, actually what we've got now is we've got a brand new building with a new and distinct design from the original building or buildings that we reclaimed the original steel from. So to summarise, at the moment, we see there being 7 key steps to the circular economy and to this process. So we start with the original buildings, we go through inspection, through planning, deconstruction, testing, preparation, fabrication, and new construction. As you can see, this process is currently relatively front-loaded, with a lot of the activities occurring relatively early in the design program and relative to procurement program and tender. So clearly getting early stakeholder engagement is going to be really, really key in being able to successfully reclaim and reuse steel. So, as we've outlined an actionable roadmap, why is this not happening already?
Yeah, so during our research, we've come across a few challenges, and I think it's key to note now that those challenges, we don't perceive them to be insurmountable. We really think, if the industry is set up to tackle this, we can move past them. So let's go through a couple of those now. Initially, you're going to need a client who's willing to do this. They have to have an appetite for it, and they have to be able to willing to accept things like finish. You're not necessarily going to get the same finish on a reclaimed piece of steel as you are from one off the shelf. Things like shear studs, as Ruth mentioned, shear studs can be removed from steels, but not necessarily ground flat. So painting over them, it might look a bit different, and that's something that the client will need to be able to accept. Cost. At the moment, we can't evidence cost savings, but from our initial conversations with cost consultants, they believe that we're looking at sort of, an equal cost here to buying steel new. Now, we think this is huge. If you're looking at equal cost to new steel at this stage, thinking in the future about how the supply chain can be optimized and set up to deal with this, we really might be seeing, cheaper steel being from reclaimed steel than new steel, which is really, really good. And given the cost of steel at the moment, we think that's a real benefit for clients. Timescale. Now, this is a really important one. Demolition contractors really need to be engaged very early on so that there's no implications to their program. Having had a fair few conversations with demolition contractors now, and Ruth and I actually went to site a few weeks ago to see a building being deconstructed, there doesn't appear to be any implication with time in terms of deconstructing a building in a way that's going to ensure the integrity of that steel to be reused versus demolishing a building that's just going to be recycled. So that's actually quite positive from our initial discussions. Procurement and market practices. Obviously, at the moment, the market's set up to recycle first. All demolition contractors are demolishing a building, cutting up the steel sections, sending it to a recycling facility for that to be smelted down. So that needs to change. And as I said, from early discussions with demolition contractors, that won't be a huge change for them. They just need to be notified early on. And then due to the variability of the structure, bespoke contracts are probably going to be required. At the moment, contracts are not really set up for reuse of material and using reclaimed material. There's risks associated with that. So there would need to be bespoke contracts at this stage. Stockists and fabricators, there's also an argument to say that they're not really set up to accommodate this. Despite the fact that we've had conversations with a fair few stockists about stocking reclaimed steel, some of them are already doing it and have been doing it for a long time, but not necessarily with structural open steel sections. They've been doing it with things like pipes from projects that didn't go ahead for gas lines, things like that. But they do have experience in this, just not all of them. Additionally, fabricators, they're not really typically used to working with reclaimed steel. Like I said before, it's not going to have the same sort of finish, and it might throw out issues for them. So something that they need to know about and be engaged with early on so that they can sort of alter their practices to accommodate it. And then obviously there's designers. It's going to have an impact on us, not necessarily from a structural design point of view, as we found out, but there are implications for perhaps architects and M&E engineers, and I guess structural engineers in the sense that you can't really design a building from scratch in the way that you want, in the most efficient design that you can get. You've really got to design for the structural sections that you can get from a stockist. Now, obviously, ideally in the future, stockists are going to have quite a wide range of steel, reclaimed steel for use. But at the moment, it's really about contacting the stockists and figuring out what steel they do have, designing a building for this. Now, that might result in, let's say, deeper sections. But there are benefits to this. Some of the drawbacks are obviously that architects would need to allow for different floor to ceiling heights. M&E engineers would have to be designing for deeper sections to get their plant around. But the benefits are that really, if you've got deeper sections, there's added strength in your structure, which could allow for flexibility down the line. It might not be for the use that you originally intended. So it's really tying into this, building for reuse and designing for flexibility that we want to be doing now. We want to be able to use bigger sections to allow that flexibility, but at the moment there's a embodied carbon cost associated with doing that. We can't just use bigger sections for the sake of it, saying that maybe this office is one day going to be a dance floor. We need to have that flexibility, but using new steel at the moment, there's a high embodied carbon associated with that. If you're using bigger sections that are reclaimed, because those are the only sections you can get, that embodied carbon is going to be cut down quite a lot, which we'll talk about more specifically later. But there are benefits and downsides to this.
So going on to the quality of material, not all steel can be reclaimed and reused, but a huge amount of it can. And as we discussed, an awful lot of the assessment as to whether that's the case can be done very, very early on in the process. So issues that can be a problem are things such as paint and finishes, as we've touched on. Connections can be a problem. Corrosion of the material can obviously be a problem. A significant one to note is also age. We can only reclaim steel post-1970, and this is because at this point, the UK started working towards the Eurocode programme, and steel quality was standardised at this point, which is obviously pretty important to quality assurance. And then another big one, kind of headline at the top, I've left till last, is plastic deformation. Ductility of steel is really, really crucial in ensuring the safety of the structures that we design. So it's really key that we do not see and do not have and do not reclaim and reuse sections that have experienced plastic deformation. This might be due to how the structure has been designed, perhaps a particular format of connections, style of the structure, but that will mean that some steel is not suitable for reclaim and reuse. So once we've identified the suitable steel and we know that we can reclaim it, we can reuse it, how do we prepare it and what is that fabrication process? What can we do? So as we've discussed, it needs to go through an initial preparation process, which is one of the more challenging aspects, but something that we can absolutely work through. But then once we've prepared the steel, you can essentially do during fabrication all the sorts of things and processes that you're used to doing with new or with recycled steel. So we can add shear studs, we can weld on new parts, we can weld on stiffeners, we can create new openings. We can use a whole variety, the full variety of different connection types. So how do we specify using reclaimed steel and reusing steel on a project? And who's going to take responsibility for this? As we say, from a financial point of view, we assume at the moment that the steel is likely to be bought by the developer or by the client, and there is a certain risk to this for them. So how, as a design team, can we mitigate this risk and can we reduce it? So during those initial planning and inspection stages, and by engaging with the full design team and with the full procurement and the fuller industry early on, we can iron out a lot of those issues early, like prior to deconstruction, prior to purchase. So we really know that actually what we will be purchasing and what we are going to reclaim and reuse is good quality material that we can reuse for the purposes intended. Once we've ensured that, how do we go about actually reusing it? Our contractor is obliged to use it. What can we do? So this is something, again, where I think early engagement is really, really important with the contractor who's actually going to go on and build the new structure and use the reclaimed steel. So if you can engage them early in, for instance, those testing processes, get them involved in the quality assurance, make sure that they're comfortable reusing that steel and that they have an awareness, and so that we can take it forward. So as we've discussed, this is all, there are issues, but they're all things that we can deal with right here and right now, and it's absolutely achievable even in the current market. But as it becomes more established, steel reclaim and steel reuse, how do we think this economy is going to develop further?
Yeah, so following our research, Ruth and I have been having a think about the perfect world where this circular economy is really refined into a way of working in which we think is the most efficient. So we'll take you through that now. So what we think will happen in the future, or what we'd like to see happen at least, is that you start with your steel building, as you did before, and then instead of an engineer traveling to site and inspecting that steel, the stockist who would be looking to buy the steel speculatively would be traveling to site, inspecting that steel for all the things that we talked about before. That's corrosion, openings, connections, any deformation that's been locked in. And then they'd be having the conversation with the demolition contractor, who again would have already been engaged to be made aware of the fact that there's an intention for this building to be deconstructed as opposed to demolished. So that demolition contractor would then be deconstructing that building in a way that's not going to affect the integrity of the steel. The stockholder would then buy that steel, and that steel would be transported by the stockholder to the stockyard where it's being stored. That stockholder would then send that steel off for testing. Once that's been done and the certificates have been issued and the insurers are happy, that steel's ready to be bought. Then from our point of view as designers, we'd be designing a building, having had that conversation with the stockist of, what sections do you have in stock? We've got this building, what can we use? And then our designs would go off to a fabricator. The fabricator would get in touch with the stockist, buy the correct section sizes that would all be reclaimed. The fabricator would fabricate it, deliver to site, and the building's constructed. And so that's how we see it working in an ideal world. But what is really the key point of all of this is the embodied carbon, which we'll talk about now. So how do we actually count carbon for reclaimed steel? Well, it's not as straightforward as you might initially think. Life cycle assessments, which are the calculations that we use to assess embodied carbon in a material, they're really set up to be linear calculations. Now, there are sections of that calculation that allow for recycling that material at the end of its life. But we're really looking at a circular economy and reusing that steel multiple times. We've had a go anyway, and we have come up with a figure that's been backed up by data from Aalborg University in Denmark, who've done a load of research on construction materials, their embodied carbon, but more specifically on reclaimed steel. We've sort of cross-checked the values, and we've come up with this value of 80%. Now, that's an 80% reduction in embodied carbon versus a standard section of steel. That's a huge reduction in embodied carbon. And it really has fantastic potential to start to turn around the sort of perception of steel. Steel is typically viewed, I think, as a carbon-intensive material, and we really want to start to change that. Steel is a fantastic structural material, and we want to keep using it, but we really do have to look at ways to make it more efficient, using less of it, being more efficient with our design, reusing as much of it as we can, and recycling the rest. And this is hopefully a big step on the route to that. So in conclusion, what are we going to do now? We're going to keep talking about this. We've been really excited about the opportunity to speak about the reuse of steel, and we've been really enjoying the research we've carried out so far, purely because it looks so promising, I think. We're going to keep engaging stockists and fabricators. Part of this research has really been having a lot of conversations with steel stockists and fabricators, which is not something that we always get to do. And it really helps us to understand the industry better as designers, understand their needs and what they need to be doing in order to make this happen. So that's been really good. We'll also be putting stockists and fabricators in touch with each other. So there are a fair few stockists that we've come across who, like I said, have already been doing this. But the majority of them haven't, and it's really important that that information that the stockists who've got experience with this is disseminated to others, just to help move it along and make it a supply chain that's really set up and ready to go. We'll also be engaging with more demolition contractors. We've really enjoyed speaking to a few so far, who, the actual feedback that we've got initially is that this isn't really going to impact their programs, which is really quite promising. And we've also been working with the Steel Construction Institute. We've had a few conversations with them. They're really keen to see us do more of this research and just relay more information back to them. But I think the key thing for us is really doing more things like this, actually having this webinar and trying to get that information out there, try to get people talking about it, and really look for feedback. If anybody else is doing something like this, we'd love to hear about it, and sort of put our heads together. So yeah, in conclusion,
I think, yeah, so we can do this today, I think, is the key conclusion from this. There are challenges, yes, but they are achieved. We can overcome them. It is an achievable process. We need the right collaboration, we need the right people involved, and we need to start having those conversations with people and getting that collaboration going. But reusing steel, reclaimed steel, and having reclaimed steel structures is a very realistic proposition.
Yeah, it is. And I think we're very excited about the potential for this. It really has the opportunity to offer clients saving in cost, we think, in the future, but also a huge saving in embodied carbon, which really doesn't appear to have too many downsides at the moment. So yes, thank you very much for joining. And we're going to have a look at some of your questions now. So we've got a question here. Are there currently any precedent projects that have done this? Looking at the SCI, not too many. We know that there are a fair few in Europe.
Yeah.
But the projects that the SCI seem to be quoting is reclaimed steel and steel reuse. They're really structures that have basically been constructed, deconstructed, and then reconstructed somewhere else in exactly the same form. That, as demountable structures, they're obviously fantastic. They're really environmentally friendly. But we're looking at a bit of a wider scale, really, in that we want to be deconstructing buildings that can be reconstructed in a different form. So there's added complexity there. But yes, there are some projects that are doing this post-webinar. We will be sharing this recording, by the way, for anyone who's wondering. Do we have any idea of wastage and what proportion of reclaimed steel doesn't achieve testing? Is this a barrier to market for reclaimed steel stockists?
So there is a certain amount of wastage from the deconstruction process. And I think one of the things that we've been having conversations with the demolition contractors is actually how can we start refining that process a little bit so that we get less wastage. So for instance, we blow bolts at connections more often rather than drop cutting so that we get longer lengths that we can reuse. One of the big things about, as I say, that 1970 date is to do with steel standardization. Actually, if you've got steel post 1970, we can be very confident about the quality of it. Really, it's about whether we can reuse it in terms of, has it not been plastically deformed? Can we manage the finishes? And how do we deconstruct it? Making sure that we're not damage it during that deconstruction process. So as I say, that's kind of the conversations we've already been having and really trying to work through. And any wastage can be recycled.
Yeah.
But I mean, in terms of quantities, like maybe not a sure figure on it, but I think we can certainly certainly kind of projects we've been looking at would be talking about being able to reclaim at least 80% and maybe even towards 90-95% of the steel in the building.
But that really is down to each project as well. It's very project specific. We've got a question here. Are there any stockists currently working towards this notion? I think the answer to that is yes. There are some stockists who are speculatively buying steel now. Whether or not that can translate into a project is to be seen, but it is encouraging that this is sort of already happening, and we certainly know that it's happening in Europe. So we're really just waiting for it to start happening in the UK.
I think it's one of the things that the more that the industry is aware that designers are happy designing with it, that clients are interested in looking at it, I think they're very much willing to start stocking it and start dealing with those issues, but they want to know that there is a market for them.
Yeah.
So I think that's why, things like this and starting to actually ask the questions of them and starting to have conversations with them is really important.
Good question here. Wouldn't it be easier if there was more information known about the steel, like mirrored BIM models or markings on the steel? Are you doing this in your project so it can be reclaimed again? This is a really good question. I think it's the BIM dream.
It's the BIM level 3 dream. Absolutely.
That all steel is marked and has all the information about that steel, what it's doing, the utilization. These would be fantastic things to know. And I think, are we doing this on projects? We should be doing it on projects. All projects should be doing this. And it's something that we're learning. The more we research the reuse of steel, the more we're seeing things that need to be done to facilitate that. So, if we were designing a building for future engineers to deconstruct, what would we need to be doing? So it's really making us ask questions of ourselves. So
that's absolutely one of our sort of internal lessons learned on actually what are we doing with projects.
It's a bit like waiting for an organ donor when you need an organ transplant. Or are there catalogues available on the necessary section sizes for a given project? Will structural engineers use sections that are close to those based on loading calculations or thereabouts, again, subject to availability? I think that's a really good question, Alan. I think at the moment, it's really about how close can we get? We're designing a building and we really have to work with what stockists currently have. In terms of having a list of stock, this is something that we expect to be available.
I think that's what we hope it's moving towards, where it will become such a standard process to deconstruct rather than demolish a building. And that will be something stockists start doing. You can start contact them, looking on websites, and actually you have, and as we say, the kind of the BIM level 3 dream, going towards that environment where actually you can see what is available now as reclaimed steel. This
is a good one. What would you advise contractors and fabricators to do who are interested in moving into this market? I'd say conversation, talking about this as much as possible. Like we said, there are contractors out there and there are stockists out there that have experience of this. It's just that it's not being really talked about. If contractors are offering this to clients, there are going to be more clients who are looking at this as an option. I guess the initial drive does need to come from the client, but being able to do it is being open to the idea.
I think it's realizing that everyone is interested. I think it's it's just overcoming that initial kind of getting everyone in the room, whether it's real or virtual, together, so that I think developers, clients are nervous about doing it because they think no one's providing that service, but then a lot of people aren't really providing the service. They're like, oh, we'd be really interested in providing the service, but we don't think anyone's going to buy the service. So I think it's just getting that realization that actually everyone does want to collaborate and work together on this.
I mean, we've seen that there are stockists who are providing rundowns of the material they have that's reclaimed already. So the fact that this has already started, the ball's already started rolling, really. It's just, I guess, as designers, we need to start to put not really pressure, but just the idea, the seed in the client's mind that this is something that you can do and that we're prepared to do that and take that leap of faith. Have that conversation with the stockist, have that conversation with the fabricator and get the ball rolling, really. Here we go, a couple more. What is bolt blowing instead of drop cuts?
So you literally blow the bolts out of the connection, which means that you end up almost like with the two raw plain pieces of steel. I think
we do have
this is a photo of where something's been drop cut. So I don't know if you can kind of see it through the mess of demolition activity, but a drop cut, literally they take the beam and they cut it at a diagonal so they can drop the steel down. But obviously that cut takes place a certain distance away from the connection. So you might lose, maybe 50 centimeters, maybe a full meter off the beam. Whereas if you can blow the bolts out of the connection, you essentially get left with the full original piece of steel.
Yeah, and unfortunately, that's really project specific as well. When speaking to the demolition contractors on this job, there were some steels that they could blow the bolts out of. There were some that they had to drop cut, and it was really just about access to the end of the beam. But again, this is a lesson learned for us in that if we make, and certainly architects as well in terms of their detailing, if you make connections accessible, demolition contractors will be able to drop those beams, blowing the bolts out, saving more steel, and therefore more can be reused.
So this is one of the things we can start actually doing now, like as kind of pre-activity, thinking ahead to that full circular market economy, where we actually design things that are easier for deconstruction and for reuse.
I think we'll have a last question here. In terms of scalability, how much structural steel is demolished or dismounted annually compared to its demand? That's a good question.
I would say that we still
we can't keep up with demand effectively at this point.
Yeah.
At this point, like we said really early on in the presentation,
given the amount of virgin steel we're still using.
Yeah, 98% of steel is recycled, and that's still not enough to keep up with demand, which really just highlights the fact that we're not designing efficiently enough. Obviously demand is higher now than it was in the 50s, for example, but we really need to be keeping up with that demand, designing in a better way.
It's really about getting that we reduce first, we reuse next, and then we recycle, last. Yeah.
Richard says eBay is full of steel sections, just a matter of finding them near a site. Wouldn't advise buying off eBay. Officially, we're not advising that. These steels will have to go through a testing process and be certified by a testing center for insurers to feel comfortable, and us as well as designers. Would a timber joist floor, CLT floor, or concrete covered metal deck be easier to deconstruct in the future?
I mean, I have to say, actually, when we visited site and when speaking to demolition contractors broadly, we were quite surprised actually how easy it was for them to demolish concrete decks. That came as quite a surprise to us.
Because this is composite as well. It's got shear studs, everything's cast together, and they seem to find it relatively easy to strip that concrete back. I guess more research is probably required to figure out what the best materials are for deconstruction.
Timber joist floors and CLT, we know that's relatively easy to deconstruct, but in terms of looking for suitable buildings, actually, if you've got a traditional composite frame building, it is absolutely suitable. Don't look at them and kind of think, oh no, that's going to be too hard.
Yeah, definitely. I guess we will leave it there and just say thank you very much for joining and engaging with us today. It's been really good fun, and we're super excited to talk about this more. And if you would like to talk about it more, you would like to keep the conversation going, please feel free to get in touch with either of us. We'd love to hear your thoughts. So
thank you very much for joining, everyone. Thanks for some great questions too.
Yeah, great questions. Thank you, guys. Right, I'm going to stop sharing. Thank you, everyone. Cheers.
Thank you.
Bye.